So, hello my friends. Today we continue to make exercise related to trees, and we will resolve now the exercise called maximum depth of binary tree. So let's check the condition. We need to create a method that computes the maximum depth of a binary tree such that the maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf. So we need to create a method. Let's say it will be called maxdepth, and we need to return the integer depth or 0 if the tree is empty. And here below we have an example. So this level of a tree is considered to have depth 0, this one depth 1, this one depth 2, depth 3, depth 4. In my solution I will start not from 0 but from 1, so in that case the maximum depth will be 5, but idea will remain the same. So now let me show you an example. So here we have this tree, and in that case the maximum depth for this tree is equal to 3, because this will be, for my case, you can again start from 0, I will start from 1. If we count 1, 2, 3 or 1, 2, 3, this is the maximum depth, so that's why this is the correct answer. And the main idea is that we will need to find the maximum depth of a left subtree, then to find the maximum depth of a right subtree, and then we will compare the maximum depth of these left and right subtrees, and we will choose the maximum one, and that's how we will know the maximum depth for the whole tree. And how the algorithm will work: so we will start from the root, we will go to the 9, they will go to the left subtree, and it will be equal to null, which means that we reach the leaf. And if we reach the leaf, the depth will be 0. Then we will go back to 9, we will go to the right. Again, we will see that we reach the leaf because the value will be null. The depth will be 0. We'll compare value from the left and right, and maximum depth will be 0. Then we will go back to 9 and we'll increase this depth to 1, and then we will go to 3. Again, we will increase this depth to 1, and the maximum depth for left side will be equal to 2. Then we will start to do the same process for the right subtree, and here we will have the value 3. So we will compare the 3 with 2, and we will see that so we will find out the maximum depth. So let me show how this is working dynamically. So we go to 9, we go to the left subtree, here we have null, we go back to root, we go to right. Here for left and right the depth will be equal to 0, we compare it, and the maximum value between 0 and 0 is 0. So we go back to 9, increase this length to 1, and then again we go back to the main root 3, again increase this depth, which will be equal to 2. Now we go to the right side, to the right subtree, we go on the left side, we go to the left side, here we have null, then we go back to the root, we go to the right, and the depth will be 0, we again compare, it will be 0, we go back to root, and so on. So I hope you get the idea, and in the end we will go back to the main root, and the result will be 3. So I hope you don't have any questions till that moment. If you have, please write any comments below the video, And now let's continue and let's check the implementation for that algorithm. So let's write the implementation. I really suggest you to first of all to check the previous video if trees, recursive programming and so on is something new for you, because in the previous videos I have given more details. But if these things are familiar to you, then you can proceed and to continue to watch this video. So here I have defined a structure for a node, because a node in a tree is pretty similar with a node from the linked list. Here we need to store value, and also we have two pointers, left and right, which points to the left subtree and right subtree, and a constructor here just to define a value. So let's start with implementing our method. So it will be public static, and we will return the depth, maximum depth of our tree, which means that we will return int, and let's call max depth. Like argument, we will send the root of our tree, which is the start point of our structure, which contains inside the pointers to all subtrees. So let's write here like this, root. And like I mentioned previously, here in trees we will use recursive programming, which means that we will call this method maxdepth inside this method, and if we will not put the correct condition here, it will be called infinitely times. So we need to put a condition when we want to stop, and we want to stop our recursive call when we reach the last leaf, which has the value null, because it means that we already went through all our tree, and we can stop and back to our previous root. So let's put a condition that if current root is equal to null, which means that right now we are on the last leaf, let's return 0. So if we are on the last leaf, it means that the depth will be equal to 0. Yeah, if you remember in the previous example, I have said that when we reach a leaf, we will have here the depth 0, then we will move back to the root, we will go to right. There we had an example where the right also was null, and then we compared null 0 with 0, and maximum depth was 0. Okay, now let's think what do we need to return, and we need to return maximum depth between left side and right side. Right now I just will write like this: return max, which is a method which returns maximum value between two values. I will put it like this, and then we will write the whole logic, but let's stop at that moment. Now we need to call recursively this method maxdepth for left side of a tree and right side of a tree. So let's call it. Let's write here maxdepth for left subtree, and the same for right subtree. Okay, and this method will return me the depth of a left subtree. So let's keep it somewhere. Left depth. and this method will return me depth for right subtree. And now let's compare the depth from the left and depth from the right. And that's it. So this is the solution. I hope it's clear. Again, if any questions, please reach me out in the comments and I will try to help you. And the last thing which I want to show you, that the time complexity for that solution will be ON, and the space complexity will be OH. So why so? Because we'll make so much iterations how many elements we have in our tree. And why the space complexity is OH? Because it depends on the height, let's say, of our tree, and also because we use here recursion, which is not stateless, but it's stateful, so it keeps the state of each let's say iteration, because we need to return the value. But yeah, that's the main idea. So we will see in the next video. I hope this one was helpful for you, and bye.